Hello, as we discussed in the previous video, clustering will group the similar data points. Clustering will group similar data points. What does this mean? Group similar data points can be said in two ways. First is group points which are close together, which are close to each other. You can call this, you can say this, you can group the points which are close, which are or near, which are close or near to each other. Or second way I can say is separate data points which are far from other. Separate data points which are far apart. So we have to identify. We have to identify which data points are close and far. So to identify whether the data points are close or far, we have to calculate the distance. We have to calculate the distance between data points. Distance between data points. And there are few methods. In clustering to find the distance between data points. That is known as distance matrix in clustering. We call it as distance matrix in clustering. The first one is Euclidean distance. It's very simple. You see, Euclidean distance. Formula is distance of a comma b is equal to square root of x2 minus x1 square plus y2 minus y1 square. Simple. I will explain you with a graph. We will solve one problem. This is my x, this is my y. This is my point E. Suppose this is at the point 1 comma 3. X is 1 and y is 3. Okay, and I have one more point here, that is B. This is a 4 comma 5. Consider this as 4 comma 5. This is x, this is y. Call as x1 y1 x2 y2. So now I have to find out distance between A and B. So this is my distance between A and B. If I substitute these values in the formula, then B of A comma B, distance of A comma B equal to square root of x2 is 4. 4 minus x1 is 1. 4 minus 1 square plus y2 is 5 minus y1 is 3 square. That will be 4 minus 1 is 3 square plus 5 minus 3 is 2 square. It will be square root of 9 plus 4. That is square root of 13. So this is the distance between A and B. Using the Euclidean distance, we have found the distance between two data points A and B. Very simple. Okay. Next distance matrix in clustering is Manhattan distance. Manhattan distance. The formula for Manhattan distance is distance between A and B is equal to x2 minus x1, absolute value of x2 minus x1 plus absolute value of y2 minus y1. what this is saying? Let's show with the example. I will show you with the example. This is x, this is y. This is our point A, where the value is 1 comma 3. This is our point B, value is 4 comma 5. Okay, this is x1, this is x2, this is y1, this is y2. So how is it calculating the distance? It is not calculating this distance. It is not calculating the direct distance between A and B. It is not calculating this distance. No, it is calculating the distance like this. It's calculating the distance. Got it? I will draw it. I will write it neatly. So this is basically calculating distance like this. This value is absolute value of x2 minus x1. And then it will calculate the distance of this. This will be y2 minus y1. Got it? Because this is our y1. And this is our y2. This is our x1 and this is our x2, this point. So first it will calculate x2 minus s1 and then it will add the absolute value of y2 minus y1. If we substitute this in the formula, let's see, distance of a comma b is equal to x2 minus x1, 4 minus 1, 4 minus 1 plus 5 minus 3, 3 plus 2, that is 5. So the distance between A and B according to the Manhattan distance is 5, or distance is 5. Okay. Now the third distance matrix in clustering is cosine similarity. Cosine similarity. We will have the basic understanding of this. We will not go in depth. Okay, we will have a basic understanding of this because it is used in NLP, that is to cluster text data. NLP stands for natural language processing. So it is used in NLP machine learning. Okay, where we have to cluster the text data, which I have told, like example is recommendation system, document segmentation. In text data processing, we will use the cosine similarity to cluster the text data. Let's consider, I will explain you the basic of understanding this, because here the text data is NLP will go in deep, because in that NLP the text data will be converted into vectors and then it will calculate the cosine similarity. Okay, so I will tell you how the cosine similarity works, that's all. The first is, let's consider sentence A. This is our sentence A. It says eat fruits, eat fruits to stay healthy. It says eat fruits to stay healthy. And sentence B is fruits are good for health. Fruits are good for health. If you see here, the words are different. You see the both the sentence 1 and sentence B, sentence A and sentence B, words are different, but meaning is same. Both sentence meaning is same, just the words are different. So both the sentence are similar. So this is how we use the cosine similarity to identify the similar sentences, similar words. So these sentences will be converted into vectors and then the cosine similarity will apply. The cosine similarity formula is cos theta is equal to a dot b divided by mod a into mod b. Absolute value of a into absolute value of b. So this is our cosine similarity formula. If cos theta value is approximately equal to 1, then sentence or documents are similar. If it is near to 0, then not similar, then not similar. If cos theta value is near to -1, then opposite statements. These are opposite sentences. If we calculate the cost similarity of our sentence A and sentence B, sentence A and sentence B, we will get value something near to 1 because they are the similar sentences. So these are the three distance matrices you should remember in clustering. The first one is Euclidean distance, second is Manhattan distance, and third is cosine similarity. We will focus cosine similarity when we will do the NLP. Now we will focus on these two. We will use these two in our upcoming algorithms. Thank you.